Okay, so right now we're going to discuss how to translate motion diagrams into position versus time and velocity versus time graphs. So we have an object traveling at a constant rate. As you can see above, the position changes at regular distances for each second. The velocity arrows are constant and they're pointing to the right. So what I'm going to do is I'm going to take this motion diagram and just draw it vertically. We have our reference here at 2 seconds. It happens to cross through the origin. 1 second is to the left, so I'm going to call down the negative direction here. If you notice carefully, there is a positive is right, and negative is left. And 3 seconds and 4 seconds. Okay, so with the motion diagram, I'm just going to draw the dots to the motion diagram because I think it's easiest to translate the dots to the position versus time graph. So if we have 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, okay, we can take each position and carefully go straight across the screen from the vertical motion diagram and plot those points on the graph itself. So if we plot an object traveling at a constant speed, okay, we will see on the position versus time graph that the change in position is the same, and you will get a diagonal line. Now, for the velocity arrows, okay, I'm just going to draw them on the vertical motion diagram here. Now notice up in this case is positive and down is negative, just like right is positive and left is negative for the original picture. So the velocities, the positive numbers, and they would be non-zero, would be above the time axis. And those numbers don't change. So the velocity arrows stay the same, whatever it is. For example, if it's 4 meters per second, that 4 meters per second would stay the same for each of those 4 seconds. And then you would get